11.3 Perimeters and areas of similar figures. If you remember back from chapter 8, perimeters of similar figures are polygons. The polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So if the corresponding side is 4, 2, 5, one figure to the other, one side to the other side, their perimeters will be the same. Now, in this section, since we've been talking about areas so much with polygons, one thing that you notice, the ratio of these sides of this rectangle to this rectangle is 2 to 4 or 3 to 6. Those both reduce down to 1/2 or 1 to 2. But when we look at their areas, 2 times 3, this area of this rectangle is 6, where the area of this rectangle is 4 times 6, or 24. Well, 6 to 24, that would reduce down to 1/4. So the ratio of their areas is not the same. So when you double a side length of both sides, you don't just double the area, you quadruple the area. Notice there are 4 of these rectangles that fit into this rectangle. Which brings us to this theorem that says if two polygons are similar, the lengths of corresponding sides in the ratio of A to B, then the ratio of the areas is A squared to B squared. So if we took 1 and squared it, and took 2 and squared it, we could get 1 to 4. So, quick review, similarity, the definition of that, all corresponding angles are congruent and sides are proportional. And then we had ways to prove triangles are congruent. We had the angle similarity postulate. And we also had side, angle, side, where the sides were proportional and the angle between. Similarity postulate as well, I believe. And side. Okay, that's a quick review. You might need that in this chapter again. But now the ratio of the corresponding sides of two similar hexagons is 3 to 2. So corresponding sides is 3 to 2. What's the ratio of the perimeters? It's going to be the same thing, 3 to 2. Find the ratio of the areas. The ratio of the areas now is not just 3 to 2, but 3 squared to 2 squared, which would be 9 to 4. Now we can use this to analyze some word problems here. If a rectangular tablecloth is 60 inches by 120 inches, and a placemat of the same material is 12 inches by 24 inches and costs $5, compare the areas of the placemats and the tablecloths to find a reasonable cost for the tablecloth. So 12 by 24, this one is 60 by 120. So what's first off, are they corresponding? 12 to 24, 60 to 120, those sides are proportional, right? You can take 12 and multiply it by 5 to get 160, and 24 times 5 is 120. So the ratio of their perimeters, or the ratio of the corresponding side lengths, is 1 to 5. That means the ratio of their areas, so the perimeters is 1 to 5, their areas is going to be 1 squared to 5 squared, or 1 to 25. So the tablecloth is 25 times more area than the placemat. So if this costs $5, you could count on the tablecloth costing 25 times that, because that's 25 times the amount of material. So 25 times 5, it's $125 tablecloth. Pretty extreme. I don't think if it was gold laced, it might cost that much, I guess. But that would be an estimate. In example 3, a store sells trampolines that are all regular hexagons. One trampoline has a side length of 4.5 feet. And an area of 52.6 feet squared. Find the area of the trampoline whose perimeter is 67.5 feet. So the perimeter of this one is 67.5. So what I would do is I would look and figure out either what the perimeter of this one is or the side length of that. It doesn't matter. I'm going to take 4.5 and multiply it by, since it's a regular hexagon, all the sides are the same, multiply it by 6. And we get 24 and 3, 27. So the ratio of the perimeters is 27 to 67.5. So what's going to be the ratio of the areas? We're going to square that. So this is the ratio of the areas. And now I can use this to set up a proportion. 27 squared over 67.5 squared. Now remember, the 67.5 was the, oh, I messed up. I don't want 60, no, I do want that. I was looking for this. That corresponded to the 27 side length. So I want 52.6. So the small hexagon to the big hexagon is going to equal the small hexagon to the big hexagon. So this is going to, we can use this ratio. So I'm going to cross multiply and divide. And I had a calculator out, but I didn't. There we go. 52.6 times 67.5 squared. And then I want to divide that by 27 squared. We get x equals 328.75. And my units are feet squared. That would be the area of the larger hexagon. Okay, now here we're given the ratio of the areas of two polygons is 9 to 6. What's the ratio of their perimeters? So given the areas, we're going to have to work backwards, right? I'm going to say ratio of the perimeters is AB. We took A squared, B squared to find the areas. Well, if this is 9 and 16, how do we get back to A and B? We have to square these to get there. So the ratio 3 squared is 9, 4 squared is 16. We get our answer. Here's your homework assignment. I'll be seeing you soon, baboon.